Good afternoon, students. This video is for those who missed class today. So it's going to be used as a recording for you to perhaps rewatch and rewatch till you get the fundamental understanding of trace tables. Now, trace tables is basically you recording the variables at each stage within an algorithm. Now, they are going to be exam questions, and they are worth not much marks, but as I told you guys, that all your marks in your exam are important, right? All your marks in your exam are important. Let me make sure my audio is on point. Microphone sound check. Yes, right. So, seeing that every mark goes a long way for us in our exam, this is another opportunity to get easy marks, right? Easy marks on the programming section. All right, so every one of you already have this handout. So I'm gonna go through some of the basic, well, I will not do all, but I'll make sure you get the understanding of a water trace table outlines, right? Now we have some short snippets of, well, we have this Visual Basic programming language, and I would like you to transform this into Pascal code for me, not Ruby, but Pascal code for me, right? So converting this into a Pascal code, you get a fundamental understanding. Now, two things. Whenever we see the word, get my drawing tool. Whenever we see the word mod, mod returns the remainder and when we see division, division returns the whole number, right? Division returns the whole number. Right? Good. That's just for notes. Remember this. Mod returns the remainder, and the division symbol or the slash returns the whole number. Right? So let's look at this. As I said, put this into Pascal. Go ahead and test it and try it, right? So let's understand exactly what is happening there using a trace table. So to do a trace table, we have to first identify our variables. Yeah. So we have a look at table here. So here we have A, we have B, we have C, I have what they call number. Right? So for A, we are going to compute the number mode 10. For B, which is an integer, we're going to do the number divided by 10. And for C, we are going to do C plus A, and the number going to be equal to B. Now, as you could see here, we have a loop, right? We have a loop here. While number is more than 0, we're going to continue doing this entire thing as long as number is more than 0, right? So we're not going to stop until number is less than 0, right? Oh, shucks, let me undo it. Right, so let me get my eraser. Good. Nice. So we have our table here. Now we're using the number 63, right? 63. So keep in mind 63. If you have to get out your calculator, no problem, get out your calculator, and let's work this thing together. So A. So we enter a number, 63. So A says our number 63, mode 10, right? Or number 63, mode 10. Now what does mode do? Mode returns our remainder, right? Mode returns our remainder. All right, good. Sorry about that. Good. So mode returns our remainder. So 63 mode 10, or if you put in your calculator 63 divided by 10, you're going to get 6.3. Right? Now we're taking the remainder, which is going to be 3, and put it under A. Right? Then B. B says that same number, which is 63. 63 divided by 10, we retain our whole number. Our whole number there is 6. Right? Now what is C? We have not declared C previously. So C here going to be C is equal to C plus A. So you're going to be 0 plus 3 is 3. And the number going to be equal to B. What's the value of B? 6. All right, then we go again. Our number now becomes 6. So we finish with 63. Our number now going to be 6. 6 divisible by 10, or 6 mod 10, is 0.6, right? 0.6. Remember, we're taking the remainder. So we're going to put in our 6, right? That's going to be under A. And B, what's going to be under B? B now going to be 6 divisible by 10 is 0.6. So now we're taking the whole number, the number before the decimal point. So here we got 0, right? And then C going to be C plus A. C plus A. So we have 3 plus A, which is 6, which is going to give us 9. Right? And number now going to be equal to B. Right? Now, what I forgot to do previous hand is check this. Number is 6, right? So 6 is more than 0. Yeah, so we're going to do that. Why we do this twice, right? Because 6 is more than 0. Yeah? Now, 0 now, we now get to 0. Is 0 more than 0? No. So we end our loop, and that's the end of our trace table here, right? Now look at this this box below here. So that's how they got it to be A is 3, B as 6, and C as 3, right? And number is equal to 6, right? Then A now becomes 6, B became 0, C became 9, and number became 0, right? Now, let's try another one. What would the trace table be for 273? So let me clear this. All right. Let's try and remember the algorithm. All right. Good. So our number now is 273, right? So our number is 273. Yeah. So A, what is 273 mod 10? Remember, we're keeping the remainder, so we get 27.3. Right? So we're keeping the remainder, so we're keeping 3. And obviously, B would automatically be 27 since we're keeping the whole number. What would be C? What would be C? C going to be 0 plus A, which is going to be 3. Our number going to be equal to B. B now becomes 27. Is 27 more than 0? Yes. So we loop again. So our new number now comes 27. What is 27? Mod 10. We get 2.7. So A now becomes 7. B now becomes 2. And what is now C? C going to be C plus A. 3 plus 7 will give us 10. Num now becomes 2. Why 2? Because number is equal to B. The new variable, the new updated variable of B is 2. Is 2 more than 0? Sure. So we do this again. 2 divided by 10. We get 0.2 now. We keep the remainder, 0.2. B now becomes 0. What's going to be C? C now becomes 10 plus 2, which gives us 12. What's our number now? number is equal to b, 0. Is 0 more than 0? Obviously not. And we end our loop, and that's our answer for our trace table here. All right. Now you could go over, because this is a video, you could pause and go over again. All right. Let me clear my screen. Good. Now try it with try it with this number 3652, and you could also try it with other numbers. Right? Try it with other numbers. The more practice is better for you. Right? Let's look at another one. At another one. All right? Look at this. Should I pause this? Well, you could pause on your end. Look at this one. Another code, Visual Basic. Now, I would advise you to convert the code into Pascal code, and you could run it out, right? Convert it to Pascal and run it. So we are asked here to enter X and enter Y. Yeah? And we have a do until loop until Y is less than 0. We're going to do some arithmetic here. We're going to say Z is equal to Z plus 1. Remember, Z starts at negative 1. So Z plus 1 going to be now 0, right? Y is equal to Y minus X. I'm going to keep doing that until Y is less than 0. Now we want to keep track of the value of Z, right? So we have a console.write line, Z and Z. So this is just the syntax here. So Z is equal to Z. And we have read line and end, right? So we have some inputs here. We have 3 and 6. We lay out and get my drawing tool. So we have 3 and 6. All right. So X going to be 3, Y going to be 6. All right. Now Z going to be minus 1. All right. Z going to be minus 1. Now for the purpose of working, I put minus 1 here. All right. Put a comma. All right. Then we're gonna have Z is equal to Z plus 1. So Z now gonna be 1. Y going to be Y minus X. 6 minus 3 going to be 3. Sorry, this goes here. Get my eraser. All right. With me? So Y is no longer going to be 6, Y now going to be 3. Right? And then Z going to be 1. But Z was 1. Next, Z going to be Z plus 1. So 1 plus 1 will give us 2. Right? And then Y, which is still more than 0, going to be minus X. Right? So 3 minus 3 will give us now 0. Right? And as long as this is 0, can we loop again? No, we can't loop again, because now Y now becomes 0 or less than 0. It won't loop again. Right? You guys got me? Now we are keeping track. Let's try 6, 3 and 9. Now 3 and 9, I'm gonna tell you the answer beforehand. The value of Z going to be 3. Right? Look at it. The value of Z going to be 3. Right? So we have 3. Here's a different color. We have 3. And here we have 9. So minus 1. Plus 1 is 1. 9 take away 3 gonna give us 6. The value of Y is 6. Loop again. 2. 6 minus 3 gonna give us 3. Loop again. It comes 3. 3 minus 3 gonna give us 0. See that? Can we loop again? 3 plus 1. Now we're not gonna store that value because if we loop it again, the value of y going to be negative, right? So that's why we stop here. Negative, so 3, 0 minus 3, 0 minus 3, gonna give you negative 3. Hence why we stop here. Because while y is more than 0, we keep doing that. It's less than 0, sorry. We keep doing that, right? And negative 3 is bigger than 0. That's why we break out the line, right? Negative 3 is bigger than 0. If you guys remember your number line, don't get confused now. Don't get confused now. Simple mathematics, right? Simple mathematics, right? As long as the number y is less than 0, is more than 0, so sorry, we're gonna keep doing it. Keep doing it. As soon as it's less than 0, we're gonna stop, right? So if we go negative 1, negative 2, or negative 3, we're gonna stop. Right? Good. Now, again, I want you to put this code into Pascal and run it. Try these inputs. Try 3 and 6. You're gonna get the value for z to be 2. You're gonna get, if you put 3 and 9, the value of z gonna be 3. I haven't do it myself. I hope this screen is still being shared. This is being shared now. Good. Okay, this is being shared. Now, look at this, right? Look at this. So we had 3 and 6 as inputs, right? Can this be? Let's run this. So x was 3 and y was 6. You see? Z gonna be 2. Right? X was, I believe, was 3 again, and y was 9, I believe, right? And z now becomes 3, right? Remember, trace table, we're going step by step. Now I'll leave 2 and 6 for you. If you do 2 and 6, you know your value going to be? What's your value going to be? I'll leave it up to you. Your answer should be 3, right? Your answer should be 3. Now let me do it for you. So we have 2 and 6. Oh, come on. 2 for x, 6 for y, right? Values of z is 3. Now, I don't do it in my head, but I want you guys to work it out, right? Work it out. Afterward, you're going to see the trick in your head, and then it's going to be easy. It's basically going step by step to update the variable, right? Now, we have a last one here. We have a for loop here now, a for loop, right? So console, right line, enter number n. N. Now, whatever n is, for I is equal 1 to n, so if you enter 20, you're gonna go 1 all the way to 20. If you get 5, from 1 all the way to 5, right? Answer is equal to answer plus 1. Then we go next I. Next I means increment I, or I is equal to I plus 1, right? Again, do it in Pascal code syntax. You're gonna get it. All right, so let's see. Trace table for n is equal to 5. Take a break it down for you here, make it smaller. Good. So for I is equal 1 to n here in this case is 5. Answer is equal to answer plus 1. Now remember, we want to find the variable update for answer every time. So answer here is 1 because our first line of code here is answer is equal to answer plus I. I is 1, right? sorry. Answer is 1 because we initialize answer as 1 before. Sorry, my bad. All right? Answer is 1. Answer is 1 because we have initialized answer as answer is equal to 1. Now we're going to update answer. Now remember, I is equal 1 to n. So let's go. 1 now. I now becomes 1. What's answer? Answer going to be 1 plus I. What's the value of I? I is now becomes 1. So that's how we get our 2 here. All right? Next. I now becomes 2. What's the value of answer? 2 plus I. And in this case, I is 2. So 2 plus 2 will give us 4. How do we get 7? I now becomes 3. 4 plus I will give us 7, right? Because 4 plus 3 give us 7. Next I now becomes 4. 4 plus 7 will give us 11. That's how we get 11 here. Next I. And now we go on n is equal to 5. So for I is equal n, 1 to I is equal 1 to n, which is at 5. Our number was 5. 11 plus I now becomes 5. And that's how we got 6 in here. All right? We just go step by step. Step by step. All right? You guys got to watch the video again. Watch the video again. All right? So, I want you guys to try in your exercise book when n is at 7 and n is at 10. All right? If you give me your answers tomorrow, again, it would be nice if you write this Pascal code and try it out. All right? Try it out. We're trying it out to correct it. In other words, once you do your code, not Pascal, sorry. Yes, Pascal. Once you do your Pascal code, you were able to correct yourself in a sense to see if you have any errors in your trace table. All right. So that's it, guys. I hope this video is clear. I'm gonna stop this recording now and upload it for you guys.